In Greek mythology, the Muses were goddesses who provided inspiration for poetry, music, and even science. For many of us today, music is the background of our lives, providing inspiration while we play, exercise, and work. And coming full circle, technology advancements and the work of brilliant engineering minds are improving the way we hear and experience music. Stick around to learn about exciting developments in high fidelity audio ICs that could inspire you to create amazing new audio products. Welcome to Tech Chat, sponsored by Mouser Electronics, where we chat with engineering experts about the latest technical innovations that are shaping and reshaping our world. Today, we welcome back Nisshinbo Micro Devices to Tech Chats, but we have a new special guest, Joe Simanis, Senior Sales Engineer. Welcome, Joe.
Hi, Dale.
Well, it's good to have you. What are we going to be talking about today?
Well, today we're going to be talking about our Muses Flagship series of high-quality audio ICs that we manufacture.
Well, it sounds great. I'm looking forward to it.
Muses is Nisshinbo's flagship series of high-quality audio ICs that provide wonderful and heart-touching sound for music fans all over the world. They were created using Nisshinbo's superior knowledge of audio IC circuitry design and semiconductor technologies such as chip layout, lead frame materials, and manufacturing processes.
So, Joe, you mentioned that this is a flagship series, so audio ICs must be an important part of your product portfolio.
Yes, we do have many audio ICs that we would consider standard quality. They all are very good performing audio ICs, but there are people out there that really want superior sound quality, so we cater to those people as well. This is the Muses product concept. We would like to offer real, pure, and heart-touching sound. Music has the ability to affect your emotional experience in a pleasurable way. I like to say, who doesn't like music? Nisshinbo's music concept is the pursuit of high-quality sound and to reproduce the original sound with fidelity. And then we also value the importance of the listener's evaluation. Not only is it important to have good specifications for our semiconductors, but the real test is how it sounds to your ear. And by the way, the word muses comes from Greek mythology. Muses are goddesses inspiring music, dance, poetry, literature, and wisdom.
Now, I would think, Joe, that the first two as engineers, that makes sense. High fidelity, high quality reproduction. But the third one would seem to be particularly challenging because a listener's environment that they're at and or their personal taste might change. So is that kind of a particular challenge as you design these products?
Yes, it is a challenge because we have a very expensive system at our Kawagoe design facility, and I'll show it later on in the presentation. And not everyone can afford a system like that. So you may be listening it on a lower quality system. So it does depend on what you are listening from. But also, you don't want the ICs to be the weakest link in the system. So if there are any problems with the hardware, the ICs themselves, it's not going to get any better after that. So that's where, we really want to start with the IC itself and make it as best as possible.
That makes sense.
So I'd like to show some sound quality advantage of using Muses ICs. And this is a visual representation of the differences in sound quality between general products and Muses. As you can see the picture on the left, it looks a little fuzzy, faded, and everything looks very crowded together. So you could imagine that as, people on stage, and you can't really tell the difference so much between the instruments. They kind of sound similar. And then it sounds like everyone is crowded all together in the middle of the stage. On the other hand, on the picture on the right, the colors are very vivid, very bold, very strong, and all the instruments and the singer are spread out, so you can clearly hear the differences between the instruments. So we're showing that in the picture, and then we'd like to talk about all the different characteristics. So the first one is with general products, you may get low veiled sounds. So this means like it sounds fuzzy. I can't tell what instrument that is that's playing now, or who is that singer. He might not even be able to tell who is singing a song. And then unclear, poor sound separation. what did the singer say? Are all the instruments kind of blend together? Maybe you can't hear that it's two guitars playing together, or a guitar and a ukulele or some other stringed instrument. And then narrow sound field. It doesn't sound live to me. All the sound seems to be coming from the center of the speakers. And then narrow frequency range. It sounds like a cheap transistor radio. There's no bass and no highs. But with Muses, for resolution, you would say something like, I can clearly hear that that's an acoustic guitar. That's a grand piano. I can hear the lyrics. It sounds like they are live on stage. And then for localization, I can now hear that there's an acoustic guitar, an electric guitar, a ukulele, all playing the same notes. And then for the sound field, it sounds like the bass guitar is on the left of the stage, and the drummer and the singer in the center, and the lead guitar is on the right. And then finally for the frequency range, I can hear the lows from the bass drum and the bass guitar, plus the highs from the lead guitar and from the cymbals. I could even hear the audience, kind of like a hiss or whisper. It sounds like I'm live at the concert. So these are important specs for audio ICs. Muses provides low noise. So it prevents a fuzzy sound in the background or when there are quiet moments in the music. I can hear the audience in the background, or I can hear the singer breathing instead of noise. Low distortion. And this is so the signal from the output is reproduced as close as possible to the original signal from the recording. It sounds like the real thing, as if they're live on stage. Wide bandwidth. This allows you to hear the low lows and the high highs. Muses provides high slew rate. If you have low slew rate, that results in sluggish voltage changes, and this leads to distorted and smeared audio signals. High slew rate allows high frequency and transient rich musical signals. It sounds clear, crisp, pure, and real. Low crosstalk. This is good for stereo sound. It prevents the left signal from bleeding into the right signal. Low crosstalk also allows the instruments and singers to sound like they're coming from the left, center, or right of the speakers. And then finally, for electronic volume controls, these are important. You want low switching noise and soft volume steps. Muses electronic volume controls change the volume level silently and smoothly. On the other hand, potentiometers that are used for volume controls can cause a scratching sound, especially if they get old or worn out.
So then, Joe, these are kind of the electrical engineering specifications that we as technicians, technologists would be more familiar with, and they then correlate back to those more subjective experiential things you were talking about the previous slide. Is that understanding that correctly?
Yes, that's right. For instance, when we say low noise, maybe technically a person doesn't really know what that means, but I think they could hear fuzziness in audio or like some little hissing going on, especially if you're listening to classical music and all of a sudden it gets very quiet. If you hear a sound, it's not very desirable. So when the musicians are at a quieter level, you want it to be very clear, no hissing going on in the background. Does that explanation help?
Yeah, it does. And it reminds me, I'm of a certain age that I can remember when the first digital music platforms came out, when the CD came out. And I can remember the first time listening to a Pink Floyd song and it's totally silent. And then you hear the in-breath of that singer right before he starts singing, something you'd never pick up on vinyl or an old 8-track kind of thing. So, and obviously this is far beyond that capability even as well.
Yeah, and that's a good example because, sometimes when you take out some of these artifacts like noise, then you begin to hear the real recording. Like, as you said, the intake of the breath. It was probably there before, but you just didn't notice because it was kind of blended in with the noise in the background.
Exactly.
So this is a typical hi-fi audio system block diagram. And Muses ICs can perform the functions that we show in blue. And we have many different Muses part numbers for our amplifiers. So you have quite a few choices on what you can use in your circuitry. And then one of the blocks actually shows the volume control. So The two Muses part numbers are electronic volume control ICs. They could also be used in other parts of the circuitry, such as in the input, you have some buffer amplifiers. They could be used there as well. But the designer would choose where they would work best. So these are just some suggestions.
So, Joe, with this block diagram, are there some target applications where Muses is really appropriate?
Yes, there are. So target applications for Muses are home audio systems and also car audio. And then even professional audio for recording studios. And nowadays, many people have their own recording studio in their home. And then, of course, they could be used for portable audio. And then I don't want you to forget about the audio hobbyists, because many of our sales through our distributors are very small quantities where people are buying 1 to 2 pieces. So it's pretty obvious that some people are experimenting in their home and maybe swapping out Muses for another amplifier in their stereo. So I'd like to give a little history of the development of both the company and the Muses product line. First of all, New Japan Radio was started in 1959, and in 1961 they became a joint venture between NJR, New Japan Radio, and Raytheon Company. They started to manufacture semiconductors. Then in 1977 they released their first op-amp, operational amplifier, and is the NJM 4558. We still make that operational amplifier today, and it ships in very high volumes. Shortly after that, in 1988, we released another version of an op-amp, the NJM 4580, which is a popular IC for audio applications. And then in 2003, we quickly grew to number 2 position in the op-amp market. In 2009, we released our first Muses product, the Muses 01 and then the Muses 02. And these are operational amplifiers with a higher Muses sound quality. And we show our trademark and logo for Muses in the picture. And then in 2021, we released our latest flagship model, the Muses 05 IC. And then a little bit about the company again. In 2022, New Japan Radio combined with Ricoh Electronic Devices. They were both already held by Nisshinbo Corporation, and they decided to join our teams together and then call us Nisshinbo Micro Devices.
Well, I appreciate that background. It really is amazing to see the history and to see that not just the progression of technology, but be reminded that some of this technology from 1977, that's impressive that you're still selling that in volume.
Yes, it's a good part, very versatile, and many manufacturers still like it. So why change it?
Exactly. All right, now, since this is the Tech Chat, Joe, can we do a deep dive into the technology inside these Muses products?
Sure. This is our newest IC in the Muses lineup, the Muses 05. And this is a high-quality amplifier. It's got great specifications that are important for providing high-quality sound. But again, your ears are the final judge. Nisshinbo's technology and materials make additional contributions to these specifications. So you can see some of the feature specifications. So low noise, for example, 7.5 nanovolts per square hertz. And low distortion, 0.00003%. And actually, the level of human hearing, good enough to tell the difference. But again, you don't want the IC to be the weakest link in the system. So we made a lot of design choices and changes to make the distortion as low as possible. And then in your circuitry, it only increases with other components in the system. So again, it's important for us to keep our distortion number as low as possible. It also has many other good specs like high slew rate, 40 volts per microsecond, and a very wide gain bandwidth. So again, you want it to be able to produce those low lows and high highs. So that wide bandwidth of 12 megahertz is way more than you need for the audio range. But again, it won't limit your audio design.
So, Joe, you call out here a JFET input. What is it about JFETs, a pretty uncommon transistor, that is so special for this application?
Well, JFETs have very high input impedance, and that's what gives you that very low input bias current of 5 picoamps. Also, JFETs provide very low noise at low audio frequencies.
All right, what more can you tell us about what is inside these products that makes them special?
Well, first of all, I'll talk a little bit about circuit design. Special circuit design techniques are used inside Muses ICs, such as providing separate signal paths to ground to prevent mutual interference, or sometimes in the industry we call that intermodulation distortion. And then for volume control ICs, we add a switch to ground to cancel noise when the input path is opened. So again, when you have very quiet moments in the music, if we have the input path to ground, it doesn't add any noise to the audio signal. Then we also keep the transistor sizes and layouts uniform to prevent audio pops that can occur during switching of audio paths. These are key technologies to achieve Muses sound quality. The first one is circuit design, and the second one is process uniqueness. We also use special materials in our Muses products. And then finally, the fourth one is assembly technology. For circuit design, I'm showing an attenuator circuit. By providing separate signal paths to ground, we can prevent mutual interference, or this is sometimes called intermodulation distortion. By adding a switch to ground, we can cancel noise when the input path is open. This is important for electronic volume controls. Also, by keeping the transistor sizes and layouts uniform, we can prevent audio pops that can occur during switching of audio paths.
Yeah, I don't have any experience designing audio ICs, but I do remember the importance of matching those switches like you show on the right there in the layout, that they're the same size and the same layout, so that when those control signal is switching, you're kind of matching the charge injection and removal from the parasitic capacitance.
That's right. Yeah, and you audibly hear a pop sound, and it doesn't really hurt anything, but it's really annoying. So I think audiophiles don't like to hear those pops, and it's a quality perception. So if you don't hear the pops, they perceive it as higher quality.
The level of care you guys are taking, not just the circuit design, but now you're doing modifications to the process just to really raise that, get extra zeros in that number that you were showing before.
That's right. We also use special materials and a unique assembly technology. So the Muses lead frame with the Muses 05 is made with an oxygen-free copper lead frame. And this is mentioned in the previous slide as OFC. So the oxygen-free copper minimizes signal deterioration. You may have seen high-performance speaker wire in the marketplace that's made with oxygen-free copper for the same reason. And then for assembly technology, the Muses 05 has separate chips for input and output stages, again, to prevent mutual interference, or sometimes we call this intermodulation distortion. And the Muses 05 uses thicker and multiple bond wires, and this also gives better electrical conductivity.
It is really fascinating to me. A lot of times on these tech chats, I'll hear about new packaging technology, but it's usually about high power stuff, taking heat away. So this is the very first time I've ever heard about packaging technology improving signal performance and an application like this. So really incredible.
So this is our audio room in our Kawagoe, Japan Design Center. And as I noted on the bottom, goosebumps are made here. Did you ever listen to a really good piece of music and then you get goosebumps? It sounds so good, it just makes you, overwhelmed and you feel goosebumps. So at the Kawagoe Design Center, we have an audio room equipped with very high performance audio system components and speakers. We perform a lot of critical listening tests here to confirm the higher quality sound of our Muses ICs. And we do that by swapping and comparing them to other audio ICs, both our own and competitors. To me, the music sounded so good using Muses that I got goosebumps. And I was listening to a popular American rock band's album. I think you'd get goosebumps if you were there too. It sounded like the band was present and playing in the room while the music was playing. The sounds of the guitar strings were incredible. And we feel that many of the techniques that we use in Muses all contribute to a better, heart-touching sound. Let your ears be the judge to hear the difference when using Muses ICs in your design.
Okay, Joe, I have to ask, what was the band and what song were you listening to?
Well, it was the Eagles, and they were playing Hotel California. The sounds of the 6-string guitar were just incredible. It felt like they were live on stage. And I really did hear the separation of the musicians, some were on the left, some were on the right, and some was coming from the middle. It really did feel like they were live in the room.
Awesome. Well, that is certainly a classic song.
Mm-hmm. This is some demo circuit information. So in that audio room that I showed you, we actually put some sockets into the system, and then we can swap out standard parts and also competitors' parts and replace them with Muses ICs. So we did that and then performed those critical listening tests. So when I was there, they put in a competitor's op amp, played the music, and they put ours in and played the music, and they said, which one sounds better? Of course, they didn't tell me which one they put in the circuit at the time, so I did pick the Muses part. It did sound better to me. And that's why I say your ears are the most important judge, not just the specifications, but how does it sound to you?
Well, that's probably a great selling thing if you can get customers to come to the site and do that.
Yeah, that would be great. Also, I would just recommend, as some hobbyists do, that you could purchase a few from a distributor like Mouser and try it yourself at home. If you have the capability to do some soldering, you could test it out yourself.
Good point.
And this shows a signal waveform of ordinary ICs versus Muses ICs. We substituted an ordinary amplifier IC with a Muses amplifier IC and compared the output signals of each one. This is a graph of the ordinary signal superimposed onto the Muses signal. You can see that the Muses output has higher peaks and valleys. The Muses is shown in kind of like a brownish color, and the ordinary signal is blue. So we put the blue on top because it's a little bit lower. So you can see that the Muses signal has more extended high frequency and more transient rich musical signals compared to the ordinary amplifier ICs. Again, your ears can hear this difference between the high quality Muses signal versus the lower quality ordinary IC signal.
And here we're just seeing the peak-to-peak differences, basically, but that's going to be related to the distortion. You're losing those high-frequency signals you talked about. Underlying all the differences in the signal is just going to be a lot of differences in the frequency spectrum of what you're hearing.
Yes, that's right. There are other instruments that you can use for measuring the frequency. And so in those, you would see that there are more frequency components that make it more transient rich and better sounding. It's a little tough to show it in this picture. So again, your ears are the best judge because not only can you verify visually, but with your ears, you can pick up those extra transients that are missing from the ordinary ICs. I'd like to talk about some plans for improved sound quality. For the future, we have ideas to further improve sound quality, such as developing new Nisshinbo power management ICs to provide clean power throughout the audio lineup. Stay tuned on that.
Excellent. Now, for our audience members who are interested in learning more, what types of resources do you have available at the Nisshinbo website to help them get started with their designs?
Well, first of all, on the website, you can access our data sheets, and we do have some evaluation boards as well. So we can work with you to get an evaluation board in your hands, and you can quickly test it out, and you can hear the difference before you proceed to do a layout in your design.
Very good. Joe, before we wrap up this tech chat, is there anything else you'd like to share with our audience or any other special takeaways?
Yes. First of all, on our website, we have a design support section, And there's an article how noise affects analog semiconductors. And then we have SPICE models. And then you could always contact us and we can link you with our engineering team for further support.
Excellent. Well, I would encourage our audience to go check that out. Joe, it's been great having you on Tech Chat today.
Thanks, Dale. It was a lot of fun, and I enjoyed explaining Muses to you, and I hope that everyone gets a chance to try them out and listen for themselves.
I do too. And as we wrap up today's Tech Chat, we want to thank our sponsor, Mouser Electronics. If you are looking to purchase any of these amazing Nisshinbo products or other electronics components and supplies, I would encourage you to head over to Mouser.com to thank them for supporting educational presentations like this. And join us again next time on Tech Chat, where we chat with the leading technical experts like Joe Simanis from industry-leading innovators like Nisshinbo Microdevices, who are changing our world every day.